to draw each thing in a standard position, we actually have to think of our Cartesian plane when we do this. I know that one got a little crooked there. And what we're really trying to deal with is our original angles go from 0 to 360 degrees, okay? Which also means going from 0 to 2 pi, okay? So this is our degrees and this is our radians when we're doing it. Whichever you're more comfortable with, it's good if you get good at answering both. The first one, 520, you can notice already, that's outside. It's greater than 360. So essentially what it means, it's going to do a full rotation, and then we'll see what's left with 520, okay? It just, degrees tends to be something we're used to working with because we've done it a few more times up to this point. Radians are a bit new, so actually we'll start with the degree question, and then we'll go into the converting of the radians. One way you can do this is you can take 520 and actually just subtract 360, okay? And in this case, you're going to end up with 160, I believe. So now, what this really is it's a full rotation all the way around, and then we're moving 160 degrees, which is something like that. I should have used a straight line, but this is about 160 degrees, okay? So that's what our 520 happens to be. It happens to be 160 degrees of a drawing here. What we can do with this is we can find out exactly how this relates to any potential special triangles. In this case, actually, it's only a difference of 20. Whenever you're referring to a special triangle or you're trying to make a triangle out of an angle, we always draw a vertical line down to the horizontal axis, the x-axis, what we usually refer to it, okay? And we usually try to make this arm 1 unit long. That's the way we're working with a unit circle when we do stuff. So our hypotenuse here happens to be 1 unit long. This internal angle is 20 degrees, and we know that this is 90 degrees. That would mean this is 70, and we could technically use SOHCAHTOA to find out the 2 side lengths of this, and we could actually do some kind of a measurement of the triangle. But the same stuff, we can actually still use our converting to radians to do that also, okay? So we can also convert this value to radians, 160. So I'm going to do that in the bottom right corner. Remember, if we're converting to radians, this is degrees to radians, we're going to multiply by pi over 180, okay? And when we do that, if I divide both of these by 20, I should get, the zeros disappear, and we get 8 pi over 9. Okay, so that would actually be our radian value in our standard. That radian value is what we have as this movement around the Cartesian plane. The other one we're working with, 11 pi over 6. If you take a look, 11 pi over 6, if you think about it, that's actually less than 2 pi. Okay, so when it's less than 2 pi, that means it's actually within a full rotation here. So if I were to actually go all the way around, it actually stops before we get here. In fact, it's exactly 1/6 or pi over 6 short of being 2 pi, right? You could make a little argument that if I just have one more, if we were to do a little addition question here, and we were to add a 12th pi, well, 12 pi over 6 can be reduced to 2 pi, and 2 pi would be 360 degrees. So you could make a point that this one is actually 11 pi over 6, which also means if you were to build that special triangle again, remember this being the unit circle, okay, this being 90 degrees, you can actually try to figure this out using your special triangle information too. With your special triangle, pi over 6, we can actually, let's go down the page so we have a little bit of room here. Pi over 6, we could try to figure out what that is in degrees and then use a special triangle to kind of find out some of our other stuff. So let's say we're going from radians to degrees like we had done in the last question. 11 pi over 6, and in this case we multiply by 180 over pi like we had just talked about. Pi cancels out, 6 goes into 180 30 times. So this actually becomes 11 times 30, which is going to give us 330 degrees. Okay, so we know that this entire rotation is 330. That means this internal angle of the triangle is actually 30 degrees. So if we have 30 degrees, there's actually a special triangle that plays into this for us, okay? So let's keep in mind that special triangle. This is what we had done in that last assignment. If we have an angle that's 30 degrees and another one that's 60, okay, we have our triangle that is 1 root 3, 2, but we could do some reducing to make this the unit triangle. This is what you would have done in that last little assignment. We could take this exact same triangle, and what we're going to do is we're just going to divide all the sides by 2. And the reason we're going to do that is because we're trying to make the hypotenuse the value of 1. Okay, we want this to be 1 unit long. That's the length of the unit circle we're using. So instead of being 2, we take 2 and we're going to, using similar triangles, we're going to divide every value by 2. The angles will still be the same, 60 degrees and 30 degrees. Okay, but in this case, we'll have a half as this side, and this will be root 3 over 2 as this distance. So that's all the information you'd really need for looking into these two values here. I'm going to zoom out a bit so you have a better view of this. Okay.